Racing. Today what we're going to look at is a common question, which is what is my stud diameter and thread pitch? So we're going to show several ways how to measure it today. Obviously the end result is you want your lug nut to screw correctly onto the wheel stud. But before we talk about the thread pitch and the diameter of the stud, let's talk about what the studs do on a wheel. Wheel studs are designed to clamp the wheel to the vehicle. This device here is a piece from one of our show rigs, and it's serving today as our mounting flange, showing the stud location and the wheel face location that mounts to the wheel mounting face. What a stud does is it clamps the wheel to this surface in such a way that this surface friction between the wheel and the mounting face actually drive the wheel. The stud is designed not to be in shear, but always be in tension, in other words, clamping only. So if the stud's properly torqued and we don't exceed the capacity of the stud clamping force to lock these two pieces together, then the stud doesn't take shear, we don't break any studs, and everything is just fine. The other thing about a stud is that the diameter of the stud and the pitch of the threads determines its clamping force and how many foot-pounds of torque it takes to get to that clamping force. Because ideally what we want to have happen is we want to slightly stretch this stud so that it acts like a spring, meaning that it's stretched and the steel is acting like a spring and holding the tension all the time regardless of temperature throughout the operating cycle of the vehicle. So the amount of torque required is enough to stretch the stud, but not enough to break it. Also, if we don't stretch the stud at all, what happens is that the lug nut will work loose because it's not under a constant clamping load. And so what happens is this will not stay tight. As soon as it loosens, we lose the friction between the wheel and the mounting face. When that happens, then the wheel will slip, shear the studs, and the wheel comes off the vehicle. Obviously, we don't want that to happen. So let's look at how to measure this stud. Now, there are a number of ways to do it. One of the ways is you get one of these kits that has a number of these little devices here which simulate the stud end and the end for the nut. You can take the nut if you're checking the nut and screw onto it. That one happens to fit. And it says here that it is a 1/2 inch by 20 right hand. Now, nearly all studs are right hand, but there are a few that are left hand, so you have to be careful. If they are left hand, typically there's an L stamped on the end of the stud, so look at that before you decide which way to turn it. But again, 90% of all the studs out there in the automobile world are right hand. So again, how do we check this? We can check this by screwing this down. And what that will do is tell us, okay, great, this fits fine. It is a 1/2 inch right hand 20. The lug is a 1/2 inch right hand 20. And we do see them fit together. So that would be ordered properly. There's another way to do it. You can purchase one of these. This happens to be from the Thexton Corporation. And this is a way to measure the stud diameter. We can, okay, that's too big, that's too small, pretty straightforward. And when we look at it, we see, yep, that's a 1/2 inch. Then we need to know what the thread pitch is, so we put our threads up, and we hold it, and we check. Okay, nope, that doesn't fit just right. That definitely doesn't fit. That's a little better. And that's a perfect fit, and just to check, we go on the other side, and of course it doesn't fit again. So the teeth drop into the grooves perfectly, and we do show it's 20 threads per inch. Again, so we know it's a right hand, 1/2 inch right hand 20. So that does fit. So there's two methods right there to use for that process. The stud range, the torque range for a stud is something that is dependent again on the thread pitch and the stud diameter. The thicker the stud, the more torque it takes to stretch it. And the finer the thread, in other words, the more angle the thread has, the less torque it needs to stretch it because you have more mechanical advantage. So if you had a stud that was, say, a 14 millimeter by 2.0 versus a 14 millimeter by 1.5, which is the metric way of measuring threads, then you would say, well, it's going to take more torque on the 2.0 thread pitch than it is on the 1.5 to give me the pull I need, and you will find that in those cases the 14 by 2.0 will require more torque because it doesn't have a mechanical advantage and to stay tight. So again, when we look at thread pitch, stud diameter, we can talk about it in inches, like a 1/2 inch right hand 20, or a 7/16 right hand 20, or a 9/16 right hand 18, or we can talk about metric, which is in millimeters, a 12 millimeter by 1.5 or a 12 millimeter by 1.25. What is meant by the 1.25 is that instead of measuring how many threads is in an inch, we measure what one turn of the thread is in millimeters. So 1.5, one turn of the thread, if I were to turn the fastener one turn complete, it would move up or down on the stud 1.5 millimeters. If it was a 2.0, then it would move 2 millimeters, and if it was a 1.25, it would only move 1 1/4 millimeters. So those are the two methods that are used for determining pitch and stud diameter, and then of course torque. Hopefully that answers all your questions. You can take a look at other detailed information at www.weldracing.com.